For a calculation of the final value, the function f of t should be defined at t equal to infinity. The function f of t should be defined at t is equal to infinity. Suppose f of s is given as like this. Suppose f of s is given as like this, 1 by s minus 3, and one more f of s is given like this, 1 by s plus 2. First listen. If you did not mention anything about the ROC, the signal is to be right sided signal, and the right sided ROC, and the corresponding signal in the time domain is the right sided signal. Corresponding signal in the time domain is the right sided signal. Right sided signal. So if you consider the slope, consider the poles of the system are at this 1, 2 and -1 and -2. If you consider the poles of the system are at 1, 2 and 1, -2, and the signal is the right sided signal. Signal is the right sided signal. If we did not mention anything about the signal, then the signal will be considered as the right sided signal. The corresponding ROC is the right sided ROC. Corresponding ROC is the right sided ROC. Listen, here the ROC may be sigma greater than 2. Maybe sigma greater than 2, or maybe sigma less than -2, maybe sigma less than -2, or maybe sigma less than 2. What is the ROC of this? Possible ROC of this one? If you consider only two slopes, -2 and 2, the possible ROC of these are sigma greater than 2, sigma less than -2, sigma less than -2, and -2 less than sigma less than 2, -2 less than sigma less than 2. And one more thing you have to consider, the corresponding equal to having slope only in the left hand side, and one more thing, the corresponding is equal to slope pole only at right hand side. So for this possible is equal to sigma less than -2 or sigma greater than -2, and here is equal to sigma greater than 2. Since we are talking about the right sided signal only, by default we consider the right sided signals only. The corresponding ROC is the right sided ROC. Corresponding ROC is the right sided ROC. We will discuss about this one. Corresponding ROC is the right side ROC. Now, from this, the corresponding f of t can be represented as this f of t equal to, simply we can say e to the power 3t u of t, e to the power 3t u of t. Now, corresponding this f of t is equal to e to the power -2t u of t, e to the power -2t u of t. As t tending infinity, this value is going to be infinity. This value is going to be infinity, and so we cannot say the system is a stable system. We cannot say the system is a stable system. As t tending infinity, this value becomes equal to 0. And you can say the system is stable. This is nothing but what is the condition for the stability of the impulse response of the system? That is integration minus infinity to infinity. That h of t should be less than infinity. H of t will be less than infinity. In this case, if we consider this limit, integration 0 to infinity, e to the power 3t dt, this value is going to be infinity here. If you consider here 0 to infinity e power -2t u of t, the corresponding is of finite value. So you can estimate the here the system is said to be unstable system. Here the system is said to be unstable system, and here the system is said to be stable system. Now listen. Here where the pole is exist in the right hand side. Pole is exist in the right hand side, and in this case the pole was exist in the left hand side. Pole was exist in the left hand side. According to the given signal is considered as the right hand sided signal. The corresponding ROC is in the right hand side. This is the corresponding ROC here. What about this one? This is your corresponding ROC here. This is your corresponding ROC here. Okay, ROC contains the j omega axis. Then the corresponding system is said to be stable. Okay, ROC having the j omega axis, includes the j omega axis. Then the corresponding system is said to be stable. Because this system 1 by s plus t is a stable system. Already we got. And in stable system means we can estimate the final value. As t tending to infinity. Okay, in this case, if the pole is exist in the right half of the S-plane, it is not includes the j omega axis. Of course, the system is said to be unstable. On that cases, we cannot estimate the value of the final value as t tending to infinity. So for all the right sided signals, if it is having 5 more poles, and the signal is the right handed signal, ROC should be a right hand sided. Though ROC should be greater than this pole, greater than the least pole. This value is something here -1, -2, -3, -4, adding here 4 poles. those are at -1, -2, -3, -4. And corresponding ROC is at the right side here. ROC is greater than -1, then only j omega axis includes in the ROC, and the system is said to be stable. Finally, we can conclude that for the right sided signal, it is said to say the right sided signal is said to be stable. It is said to be stable. All poles of that should be lie in the left half of the S plane. If any one pole lie in the right half of the S plane, because of the right sided signal, ROC should be right hand sided. As ROC is right hand sided, the j omega axis will not include in the ROC. The system may not be stable. As the system may not be stable, we cannot estimate the final value of the signal in the time domain. That is nothing but as t tending to infinity, we cannot estimate the final value. So final value. From this we can conclude what we conclude that we have to observe whether the given system is stable or not. Before calculating the final value, we have to observe whether the given system is stable or not. How can you estimate? But just draw the pole zero diagram, draw the poles on the S plane, and we have to take the ROC. ROC should be always in the right hand side. By default, it did not mention anything in the question. By default, you can consider the signal as the right side signal. Now, what about the ROC? And is there j omega axis exist in the ROC or not? If exists, then the system is stable. No doubt at all. We can calculate the final value. If not exist, the system is unstable. We cannot calculate the final value. If suppose in the question they mentioned left-handed signal. If suppose in the question they mention left-handed signal, then as a right-handed signal, pole should be in the left half of the S plane. But in the left-handed signal, pole should be in the right half of the S plane, because as a left-handed signal, ROC is of the left side. And whenever pole lies in the right-hand side, then only the corresponding ROC contains the j omega axis. If the pole on the left half of the S plane, the corresponding because of the left side, ROC is of the left side, the corresponding ROC does not include the j omega axis. At that situation, we cannot calculate the final value using the final value theorem. We cannot estimate the final value using the final value theorem. Okay, the condition by applying the initial value theorem, the condition you have to verify is that whether the degree of the numerator is greater than the degree of the denominator, then we cannot estimate the initial value by using the initial value theorem. For final value, if the system is unstable, there is nothing but if there is any pole in the right half of the S plane, we cannot estimate the final value using the final value theorem. These two conditions you have to verify clearly. Next, one more. If suppose pole exists on the j omega axis, there is nothing but the situation where the function is where f of t is of the oscillatory in nature, where f of t has the oscillatory in nature. That is nothing but f of s is equal to, suppose they have given omega naught divided by s square plus omega naught square. That is nothing but poles exist on the imaginary axis. This is the size for oscillatory in nature. The corresponding f of t is equal to sin omega naught t. Sin omega naught t is the value lies between oscillates between 1 and -1 continuously. So we cannot estimate the exact value where it was stopped. It oscillates because it's oscillatory in nature. It oscillates between +1 and -1 continuously. We cannot estimate at what value is the corresponding final value as determined in infinity. For this case also we cannot apply the final value theorem. So the final value theorem apply only for the signals those are having the stable signals. As stable signals only. That is nothing but the poles those lies in the left half of the S plane for the right-handed sided signals. For those signals only we can apply the final value theorem. What about this initial value theorem cannot apply because at every value of the time this is going to be oscillates. We cannot predict at what value it may be stops. So these two conditions you have to verify. Be careful while applying this initial value theorem and the final value theorem. We want to do some questions on this. If given f of s is equal to, simple questions we can consider. Given f of s is equal to s square plus 3s plus 1 divided by s plus 1, then what is the corresponding initial value and the final value? Initial value is equal to how much they are asking. For initial value, we have to verify whether the degree of the numerator is greater than the degree of the denominator. Then we cannot determine the initial value cannot be determined because because in the f of t we have the terms of the del dash derivative of the impulse and impulse functions. Impulse function, for the impulse function we cannot estimate the value at t equal to 0, at t equal to 0. Now for the final value, we have to verify whether the poles lie in the right hand side or not, whether the poles lie in the right hand side or not. If right hand side is available, then we can directly write down the final value theorem. First of all, we have to calculate the f of t. Even though you are having the doubt, just calculate the f of t. That's it. Just calculate the f of t. F of t is equal to, simply you can write s square divided by s plus 1. S square divided by s plus 1 plus 3 into s by s plus 1. Plus 1 divided by s plus 1 plus 1 by s plus 1. This is your f of s. This you can write simply for 1 by s plus 1 equal to e power minus t u of t. 2 times of differentiation is required, right? 2 times of differentiation is required because of this s square. 2 times of differentiation e power minus t into u of t. 1 time differentiation e power minus t into u of t. Again differentiation is e power minus t into u of t, minus plus, and this will become e power minus t into u of t. 2 times of differentiation. 2 times of differentiation here for 1 by s plus 1. For 1 by s plus 1, the corresponding is equal to e to the power minus t u of t. d by dt of this e power minus t u of t is equal to your s by s plus 1. d by dt of again differentiation, this will give s square divided by s plus 1. S square divided by s plus 1. Anyway, in the final term we have the negative term e power minus t u of t plus minus 3 into e power minus t u of t, and this one this one is equal to e power minus t u of t. Each and every time you are adding the negative term only. Because of this minus, as t tending to infinity, this value is going to be 0. This value is going to be 0. So definitely the system is stable. Otherwise, from the given function, the pole is existing in the left half of the exponent. Definitely the system is stable, and we can estimate the value, and we can calculate the final value. We can calculate the final value. The corresponding final value is equal to limit t tending to infinity f of t is equal to simply limit s tending to 0 s into f of s, s tending to f of s. So this value is equal to simply s tending to 0 s into s square plus 3s plus 1 divided by s plus 1. This value is equal to 0. This value is equal to 0. So final value is equal to 0. Initial value cannot be estimated. Consider one more question. This f of s is equal to s plus 2 divided by s plus 3 into s minus 1, s plus 3 into s plus 1. What is the initial value and final value? What is the initial value and the final value? Here the degree of the numerator is less than the degree of the denominator. So you can definitely apply the initial value theorem for the calculation of the initial value. For corresponding is equal to limit t tending to 0 f of t is equal to limit s tending to 0 s into f of s. S tending to infinity s into f of s. So this can be represented as s plus 2 divided by s plus 3 into s plus 1, as the degree of the denominator is greater than the degree of the numerator. So this by the limits concept, you can represent this value is equal to 0. Since 1 by infinity you will get, and this value is equal to 0. Now coming to final value. For the final value, you have to verify whether the given system is stable or not. Given system is stable or not. Given all the poles are lies in the left hand of the exponent, so definitely the system will be stable. Definitely the system will be stable. So you can apply directly the final value is equal to limit s tending to 0 s into f of s. This is equal to simply limit s tending to 0 s into s plus 2 divided by s plus 3 into s plus 1. This value is also 0. This value is also 0. Suppose if there is a function like this s plus 2 divided by s plus 3 into s minus 1, then what will happen? For initial value, there will be no changes. Initial value is equal to 0 only. For the final value point of view, there is one pole exists in the right half of the exponent. One pole exists in the right half of the exponent. ROC is sigma greater than 1. ROC does not include the geometric axis, and so we can say the system is unstable. We cannot estimate the final value using the final value theorem. In the final value theorem, right, cannot be determined. This condition we have to verify. But we have to verify before applying this initial value theorem and the final value theorem. It is a very easy concept. You have to keep this point in your mind. You have to keep this point in your mind. Okay, suppose if f of s is equal to 1 by s plus 1 into s square plus 1. If f of s is equal to s divided by s square plus 9 then what is the final value and the initial value? For this situation also we cannot estimate because this is the oscillatory nature. The corresponding is equal to cos 3t. These 3 points we have to keep in our mind. The corresponding is oscillatory in nature. We cannot estimate the final value using the final value theorem. The 3 points before applying this initial value theorem and the final value theorem we have to remember is that first one is that for applying the initial value theorem, degree of the numerator should be less than the degree of the denominator. And for applying the final value, final value, the system should be stable. There is nothing but we have to verify all the poles of the given system should be lie in the left half of the S plane, should be lie in the left half of the S plane. And third one is whether the given signal is having the oscillating nature in the time domain or not. If oscillating nature, simply rule out, cannot be determined. Otherwise, in the options if we have, if you in this initial value theorem and the final value theorem calculations, in the options you are having the term cannot be determined. Definitely you have to verify. Don't write blindly. In the options, if you not having the cannot be determined, go blindly. Okay, right? We pick up any option blindly by doing the thing of x equal to 0. If there is option cannot be determined, you have to think once. That cannot be determined. Not only for this question, in any question the option is available, cannot be determined, none of the above like that. You have to think about the question clearly. You have to do the calculations clearly. Now, unilateral Laplace transform and the bilateral Laplace transform. What is the unilateral Laplace transform and bilateral Laplace transform? Don't bother. Unilateral Laplace transform also a Laplace transform only, but here we consider that t limits are from minus infinity to infinity, minus infinity less than t less than infinity. In this unilateral Laplace transform, we will consider only 0 to infinity. As we consider only 0 to infinity, but nothing but the corresponding signal is said to be a right-sided signal. So, in the unilateral Laplace transform, by default it is a right-sided signal. Until now we have considered the right-sided signals only. Not only in this one, in convolution, in your mathematics, wherever the Laplace transform applications are there, everything are the unilateral Laplace transform, unless until they mention that the bilateral Laplace transform, all are the unilateral Laplace transform only. No need to mention or no need to write the ROC or like that. So the answer should be right always along with ROC. You have to write along with ROC. Here, no need to mention the ROC because by default it is a right hand sided. Then we have to consider both from minus infinity to infinity. Suppose they ask you to calculate the bilateral Laplace transform of the one. If here is equal to u of t plus u of minus t, you have to consider u of t plus u of minus t plus u of t, you have to consider. Consider the corresponding is equal to minus 1 by s, the corresponding is equal to 1 by s, but sigma less than 0, sigma greater than 0, so we cannot write down the bilateral Laplace transform for the 1. Suppose if they ask you to calculate what is the unilateral Laplace transform of 1, what is the unilateral Laplace transform of 1? Unilateral Laplace transform 1, the corresponding is equal to simply u of minus t, temper it will exist in the negative side, so you have to consider only the positive part. Indirectly, this is equal to u of t only, 0 plus u of t, that is u of t only, corresponding is equal to 1 by s. So, in your control systems or in your mathematics or any applications of engineering using the Laplace transform, if there is any DC signal is there, directly we will take the corresponding Laplace transform is equal to 1 by s. If suppose in network theory 5 volt source is given as the input, 5 volt source is given as the 5 volt source is given as the input to the circuit. Input to some random circuit. At that situation, the corresponding Laplace transform we will directly take as the 5 divided by s. But in the concept of Laplace transform for the DC, we will learn that for the DC signal we cannot determine the Laplace transform. How can we take in the network theory and the control systems the corresponding Laplace transform is equal to 5 by s? Since all those cases, by default is the right-sided signal. By default is the only right-sided signal. So the corresponding right-sided signal for the corresponding unilateral point of view, the Laplace transform of the DC signal is equal to 1 by s. This signal is equal to 1 by s. Right. If they mention the bilateral Laplace transform, we cannot get the Laplace transform of this one. There should be no common ROC. Then next one. What is if they ask you what is the Fourier transform u of t plus 2? What is the Fourier transform of u of t plus 2? Using the bilateral Laplace transform, this is simply equal to e to the power 2s divided by u of 2 plus t. Nothing but the function starts from minus 2. This is equal to e power 2s divided by s. What about this in the unilateral Laplace transform? For this case, u of t plus 2 unilateral Laplace transform. For this case, what will happen? As it starts from t equal to minus 2. Even though we are not supposed to consider these This is to be approximated as this one only. The corresponding to be considered as the 1 by s only. The corresponding to be considered as the 1 by s only. If they ask you what is the unilateral Laplace transform, this u of t plus 2, the corresponding is 1 by s only. How to consider? Now next one. Next one, bilateral Laplace transform. In bilateral Laplace transform, we have consider the corresponding d cube f of t divided by dt cube equal to simply you have done s cube into f of s cube into f of s. Since the signal start from minus infinity, the signal start from minus infinity to infinity. Before infinity, nothing is there, right? Before infinity, nothing is there. So directly you can write this equal to s cube into f of s. Whereas in the unilateral Laplace transform, listen. Whereas in the unilateral Laplace transform, if we consider d cube f of t divided by dt cube, as it starts from 0 to infinity, there may be something before this minus infinity, before this 0. There may be something before this 0. So we have to subtract the something. So finally they arrived that the subtraction is equal to s cube into f of s minus s square into f of 0, small f of minus f square into f of 0 minus s into f dash of 0 till and up to how much you have to do? Up to the term s power 0 you have to write minus s to the power 0 into that is nothing but s power 0 is nothing but 1 only into f double dash of 0. These values you have to subtract. So d cube of t by dt cube is nothing but they have given like this. If in the course already we have done two questions in the yesterday class. If they mention the initial values, you have to consider all these conditions. You have to consider the expression like this, and after that only you have to estimate the forced response, free response, total response. That already we have seen. What is free response? Without input is free response. Only initial states we consider, that is free response. Forced response is only input is considered. Total response is both because of the input and because of the initial values. This is only the concept of bilateral Laplace transform. This is only. Okay, this is having importance in the university examination point of view. They may ask you the theoretical information also about this one. So for your this examination, gate examination point of view, this is not that much important. Now coming to the periodic, the signal f of t is given as like this. Then what is the Laplace transform of this one? The signal is given like this: pi, 2 pi, 3 pi, 4 pi, 5 pi, like that they have given. They ask you to calculate the Fourier transform of this one. Suppose I am considering a small signal g of t equal to like this. For this type of situation, this is looking like a period, not a periodic signal. Periodic signal means there should be a edge from t equal to minus infinity to infinity. Looking like a periodic signal from 0 to infinity. The same signal is repeating for equal intervals of time. So you can consider this as a periodic signal from 0 to infinity. The corresponding signal, whichever is the repeating, you consider the separate signal as g of t. Whichever is repeating, the corresponding signal to be considered as the g of t, and this can be represented as this f of t equal to summation of the shifting version of the c of t only. That is nothing but g of t plus g of t minus pi is nothing but this plus the shifting version of this one. This is from pi to 2 pi. By adding these two, you have this one only. By adding this two, you have this one only. One more if you add, that will become plus g of t minus 2 pi. Just g of t minus 2 pi up to so on. If you take the corresponding Fourier transform of this one, is equal to f of s into g of s into 1 plus e to the power minus pi s by shifting property plus e to the power minus 2 pi s plus up to so on. Suppose instead of pi, if it is having it is repeated for equal intervals of time t, then you can represent the corresponding f. In general, I am writing the corresponding f of s equal to g of s into 1 plus e to the power minus ts plus e to the power minus 2 ts plus e to the power minus 3 ts up to so on. So this is looking in the geometric series only, right? So the summation of the series equal to g of s is equal to a divided by 1, g of s into a divided by 1 minus r. What is r? R is equal to second term divided by first term is equal to e to the power minus ts by 1 e to the power minus ts. So this will become e to the power minus ts. We can represent this as a formula. I told you never represent any formulas. E to the power minus ts. So if you never represent remember any formula. So in our question you have f of s equal to g of s into 1 plus something. From this we can represent here t is equal to pi only, or otherwise this is also looking like infinite series. From this we can write f of s is equal to g of s into a divided by 1 minus r. That r is equal to here e to the power minus pi s divided by 1, which is equal to e to the power minus pi s. So this can be represented as g of s into 1 divided by 1 minus e to the power minus pi s. What about this g of s? G of s already we have calculated, right? G of s is already we have calculated. What is the g of s? The g of s is simply sin t multiplied with the g of t is equal to sin t multiplied with the your pulse. Sin t multiplied with your pulse from 0 to pi. This can be represented as sin t into u of t minus pi. Like that we have calculated whatever the answer you will get in the g of s. You have to substitute here and substitute here along with multiplication of 1 by 1 minus e to the power minus pi s. The signal is like this. This is called the periodic Laplace transform. They can call periodic Laplace transform. They can call. And one more signal is if the signal is like this. The signal you have to approximate. You have to approximate. That's it. Nothing is there. Not anything here. Suppose the signal is like this. Then what will happen? Suppose the signal is represented like this in the steps format. Here is 1, 2, 3, 4, like 4 up to so on. 4 up to so on. How can you represent this one? How can you represent this one? This is simply addition of the step signals only. Suppose this is equal to u of t represented like this. U of t represented like this. Then if you want u of t minus 1 is nothing but this starts from 1. By adding these two you have like this, right? You have like this. If one more thing, if you add u of t minus 2, it will be like this. U of t minus 3 will be like this. So this can be approximated as u of t plus u of t minus 1. Here the value is equal to 1, here the value is equal to 2, and here the value is equal to 3, and the value is equal to 4. Represent step 1 minus 0 up to u of t. At t equal to 1, you have 2 minus 1, u of t minus 1, plus at t equal to 3, at t equal to 3, 1, 1, 2, this is what 3. At t equal to 3, you have again at t equal to 1, 2 minus 1, t equal to 3 minus 2. Here also you have 4. Here also 4. The corresponding is equal to 4 minus 3 is equal to 1. So u of t minus 2 plus u of t minus 3, like that you will get. Like that you will get. If you consider the Fourier transform of this one, this will become 1 by s plus 1 by s into e to the power minus s plus 1 by s square into e to the power minus 2s. So on like that. This by taking 1 by s into common. This is equal to 1 plus e to the power minus plus e to the power minus 2s plus up to so on. So this is equal to 1 by s into r 1 by 1 minus r. The corresponding equal to e power minus s plus r equal to second term divided by first term. This is equal to e to the power minus s. The corresponding is equal to 1 by s into 1 by 1 minus e to the power minus s. E to the power minus s. If the signal is if you see this type of signals, this type of continuous signal, very lengthy signals in the Laplace transform, just verify that this is to be compulsory a summation of the delayed version, summation of the shifted version of some signal. We have to identify that some signal. We have to identify that some signal, that is f of t. F of t. Don't think differently. Don't think differently. If you say this big much of question. Oh, I don't know. Like that. Don't think. In that we have to verify what is the common term, what is the something term which was shifted repeatedly for the addition. That we have to identify. If you identify position and identify, then easily you can calculate the corresponding Laplace transform. Easily you can calculate the corresponding required Laplace transform. Now, listen. The input e to the power 3t as the input, and the corresponding transfer function of this one h of t is equal to e power t. What is the corresponding output? If they ask you simply is equal to e to the power 3t into e to the power 3t into h of s at s equal to 3, e power 3t into h of s at s equal to 3. So this value is equal to e power 3t into h of is what is a1 h of s. H of s is equal to simply 1 by s minus 2. 1 by s minus 2 at s equal to 3. This value is equal to 1 into e to the power 3t. 1 into e to the power 3t. This is the corresponding output if they want. Suppose if they give you the input e power 3t into u of t, then the case is equal to simply 1 by s minus 3 into 1 by s minus 2. The impulse response of an LTI filter h of t is given by h of s is equal to 1 by s square plus 3s plus 1, and the corresponding input x of t is given by 2 into e to the power minus 2t, and the system produces an output y of t is equal to minus a into e to the power minus 2t. Then what is the value of a? Here the input given is the 2 into e power minus 2t. You have to observe first of all that the input is the 2 into e power minus 2t or 2 into e power minus 2t into u of t. Here the input is equal to 2 into e power minus 2t only. 2 into power minus 2t only. So the corresponding output is equal to simply 2 into e to the power minus 2t multiply with the h of s at s is equal to h of s at s is equal to minus 2, s is equal to minus 2. In place of s naught here we have minus 2, in place of s naught we have minus 2. So this value is equal to simply 2 into e to the power minus 2t multiply with the 1 divided by 4 minus 12, 4 minus 6 plus 1, and this value is equal to minus 1. So this can be represented as a minus 2 into e power minus 2t. The corresponding value of a is equal to 2 here. The corresponding value of a is equal to 2 here. Consider a small system. Consider a system whose Laplace transform is equal to another question. Consider a system whose Laplace transform is given by h of s is equal to 1 by s plus 3. h of s is equal to 1 by s plus 3. A system whose Laplace transform is equal to given by 1 by s plus 3. It is given by an input x of t is equal to some k, x of t is equal to some k. Then what is the output they are asking? What is the output they are asking? Here the input k can be represented as a k into e to the power 0 t, k into e to the power 0 t. So the corresponding output y of t is equal to simply k into e to the power 0 t multiply with the h of s at s equal to 0 here, s equal to 0 here because s is equal to 0. So this value will become ky divided by k. This is equal to k divided by 3 into e to the power 0 t. E to the power 0 t is equal to 1 only. So corresponding value is equal to k divided by 3. K divided by 3. What is the Laplace transform of? What is the Laplace transform of sine of omega naught, sine of t plus alpha into u of t, and what is the Laplace transform of sine of t into u of t plus alpha, and what is the Laplace transform of sine of omega naught t into u of t, sine of omega naught t into u of t. So this no problem. Sine of t plus alpha into u of t, sin t u of t plus alpha. For this one, you know the formula for the sin t into u of t directly. Sin t into u of t directly. If you want to write the shifting property, this should be of this form: sin t plus alpha into u of t plus alpha to be placed. But here we are having the u of t only. For that purpose, I am going to expanding this one. This can be represented as the sin t into cos alpha u of t plus cos t into sin alpha u of t plus cos t into sin alpha u of t. From this we can write directly this cos alpha is a constant. The corresponding sin t you are having this equal to 1 divided by 1 plus omega square, 1 divided by s square plus 1 into cos alpha plus s divided by s square plus 1 into sin alpha, s divided by s square plus 1 into sin alpha. Further this can be represented as the 1 by s square plus 1 into cos alpha plus s into sin alpha. So and this can be represented as the 1 by s square plus 1 into square root of a square plus b square. Square root of a square plus b square, that is nothing but square root of 1 plus s square into cos of alpha plus tan inverse cos of alpha minus tan inverse of s by 1, tan inverse of s by 1, like that we can write. Already we have seen a cos theta plus b sin theta can be represented as the a cos theta plus b sin theta can be represented as the square root of a square plus b square tan inverse of b divided by a cos of theta minus pi, where pi is equal to tan inverse of b by a, tan inverse of b by a. Like this we can represent this as the 1 by s square plus 1 into square root of s 1 plus s square cos of alpha minus tan inverse of b by a, that nothing but s by 1. So further this can be represented as the cos of alpha minus tan inverse of s divided by square root of 1 plus s square, square root of 1 plus square. Like this the option is available. Okay, options may available in this form or in this form. If it is not available in this form, don't be confused, try to convert this one. This is also very important. Already we have given in the starting basic requirement of mathematics for the single root systems. Coming to this one, sin t into u of t plus alpha. For sin t into u of t plus alpha, you have to write sin of t plus alpha minus alpha into u of t plus alpha. From this by expansion we have sin of t plus alpha cos alpha into u of t plus alpha minus cos of t plus alpha sin alpha into u of t plus alpha. Here from this the same procedure whatever we have done in the previous problem. Here this u of sin t plus alpha into u of t plus alpha. This can be represented as the e power alpha s into 1 divided by s square plus 1 into cos alpha minus cos t plus alpha into u of t plus alpha equal to s into e to the power alpha s divided by 1 plus s square into sin alpha and further simplified the same answer we will get. Along with this we have e to the power by e to the alpha s to take as a common. So we have this value is equal to e power alpha s into cos of alpha minus tan inverse of s divided by square root of 1 plus s square. Like that you can write, don't be confused. Right. Next one. H of s is equal to, what are the base characteristics of the function h of s is equal to s square plus omega naught square divided by s square plus omega naught square divided by s square plus omega naught by qs plus omega naught square. Options are given as this is your pi by 2 corresponding omega naught, like this is the first option, and second option and the third option. This is your omega naught. What is the base characteristics of this one? For anything, first we have to calculate the base of this one. This base is equal to, by substituting s is equal to j omega, by substituting s equal to j omega, you have omega naught square minus omega square divided by minus omega square plus omega naught by q j omega naught by q omega plus omega naught square plus omega naught square. From this you can represent the corresponding base is equal to be numerator of the real quantity only. This base is equal to minus tan inverse of omega naught by q into omega upon omega naught square minus omega naught minus omega square. This base is of the negative quantity, depending on the value of omega. If suppose at omega equal to omega, first you have to write at omega equal to omega naught, this value is going to be pi by 2 minus pi by 2. This value is going to be minus pi by 2 because omega equal to omega, this become minus tan inverse of 1 by 0 and minus pi by 2. So at omega equal to omega naught, this value is minus pi by 2. Clearly it is showing that this is minus pi by 2. And after this omega naught plus, immediately of omega naught plus, what is the value you have to analyze? Okay, at omega equal to 0, what is the value? At omega is equal to 0, you are having 0, though it should start from 0 and reaches to infinity at omega naught is equal to omega naught. For omega is less than omega naught, this value is negative. Since this is equal to 5 and this is 4, this value is always positive. So overall pi is negative. So omega is less than omega naught, this value is negative and reaches from 0 to 90 degrees. It reaches from 0 to minus 90 degrees. If omega is greater than omega naught, this value is positive. If you consider omega as infinity, if you take the omega square as common inside, you have tan inverse of 1 by infinity is equal to 0, tan inverse of 0 is equal to 0. Omega equal to infinity, this value is equal to 0. So from this onwards, this value is going to be increases from 90 to infinity 90 to 0. Again reduces starts from 90 and then to 0 in the positive side of this one. So this is the corresponding suitable answer. For any question, you have to represent you have to write down the expression for the base. If they ask you what is the magnitude characteristics of the function or base characteristics of the function, just try to write down the corresponding magnitude of the base, and by substituting the various values of omega, we have to analyze about the given graph. Not only for this question, throughout the ECE, for any graph point, you have to be very careful. In every examination, they are giving at least one graph based questions. In every grade, they are giving at least one graph based question for the class. Nothing. If you are seeing the graph in the question paper, simply write down the expression and substitute the corresponding values whatever they are asking. Okay, on the real, whatever they are in the real axis, and try to analyze. Simply you can get the answer. Now next one. 2s what is the inverse Laplace transform of what is the inverse Laplace transform of 2s plus 5 divided by 2s plus 5 divided by s square plus 5s plus 6. These type of questions already we have seen actually. Well, the denominator to be expressed in the form of s square plus omega naught square. Denominator can be to be expressed in the form of s square plus omega naught square. S square plus omega naught square, like that we have to write is equal to 2s plus 5 upon s square plus 2 into 5 by 2 into s. 2 into 5 by 2 into s. 2ab b is equal to your 5 by 2 whole square. So 5 by 2 whole square, then minus 5 by 2 whole square plus 6, minus 5 by 2 plus 5 by 2 whole square, minus 5 by 2 whole square plus 6. So this can be represented as the 2s plus 5 upon s plus 5 by 2 whole square as a plus b whole square. S plus 5 by 2 whole square. What about this value? This value is equal to minus 1 by 2 whole square. Upon doing 6 into 4, 24, minus 25 plus 4, minus 1 divided by 4, that is minus 1 by 2 whole square. So how can you write this one? Again, like this one, this can be represented as the 2s divided by s plus 5 by 2 whole square minus 1 by 2 whole square plus 5 divided by s plus 5 by 2 whole square. Upon taking 2s common, directly you get it. Taking 2s common is equal to 2 into s plus 5 by 2 divided by s plus 5 by 2 whole square minus 1 by 2 whole square minus 1 by 2 whole square. What is the corresponding expression? You are having 1 by s square plus omega square, s divided by s square plus omega square, corresponding is equal to cos omega t into u of t. But here you have s divided by s square minus omega square. What is the corresponding inverse Laplace transform? Already we have seen is equal to cos h t into u of t. In place of cos omega t, you are having cos h omega t. Cos h omega t into u of t. So corresponding is equal to, this can be represented as 2 into cos h 1 by 2t into e to the power 5 by 2 e to the power 5 by 2 t e to the power minus 5 by 2 t e to the power minus 5 by 2. This is the corresponding inverse Laplace transform. This one, for this purpose only I have given this question here. This don't be confused, as we are much familiar with the s divided by s square plus omega square, but we are not having much familiar with the s divided by s square minus omega square. This type of questions also they may ask you. Please remember this about this cos h omega about this cos h omega t also. Now next, what is the inverse Laplace transform of 8s plus 10 divided by 8s plus 10 divided by s plus 1 into s plus 2 whole cube? This is a simple question only, simple partial fraction expansion only, but we have to know the procedure for this one. But we have to know the procedure how to separate this partial fraction. This is equal to a divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 2 whole square plus d divided by s plus 2 whole cube. For a value we are not having any problem, directly you get right. This a is equal to limit s tending to minus 1 s plus 1 into f of s, s plus 1 into f of s. So this value is equal to simply this value is equal to minus 8 plus 10 divided by minus 1 plus 2 whole cube. This value is equal to sum plus 2. Now what about this d value? Directly I am writing d is equal to simply s tending to minus 2 s plus 2 whole cube into f of s. So this value is equal to simply minus 16 plus 10 divided by minus 16 plus 10 divided by minus 2 plus 1 minus 2 plus 1. This value is equal to how much you will get? Is equal to simply 3 simply minus 16 plus 10 minus 6 by minus 1. This value is equal to 6. Directly you may get. Then corresponding value of c you have to calculate. For c, how can you write? Already we have seen in the basics of basic parameters requirement of signals and distance at that situation is equal to s tending to minus 2. This value equal to s plus 2 whole cube into s plus 2 whole cube into, or otherwise directly you can write this value c equal to, don't be confused, just remove this s plus 2 term and we have 1 by 1 factorial into 1 by 1 factorial into 8s plus 10 divided by 8s plus 10 divided by s plus 1. I mean d by ds of 8s plus 10 divided by s plus 1. d by ds of 8s plus 10 divided by s plus 1 as s tending to limit s tending to minus 2, limit s tending to minus 2. Whatever the value you will get, our differentiation you have, this value is equal to, this value you will get is equal to minus 2. This value will get equal to minus 2. Similarly, coming to b, for b also, this is limit s tending to minus 2, 1 by n minus 1 factorial, that is not 1 by n minus 1 factorial, that is nothing but 1 by 3 minus 1 factorial is equal to 2 factorial into d square by ds square of ds square of 8s plus 10 divided by s plus 1 d square by ds square of 8s plus 10 by s square. The corresponding value whatever you get is the by s plus 2 you have minus 2 only you will get here also. So this formula is important for calculation of this and calculation of b, calculation of the b value, calculation of d value, calculation of c value and calculation of b value. Right, clear? Like this we can calculate after completion of this one. After completion of this one, directly you can get the reverse Laplace transform for this one is equal to e power minus 2t, t into e to the power minus 2t, t square into e to the power 1 by 2 into t square into e to the power minus 2t. 1 by t square to the power minus 2t directly you can write. Here the point is the calculation of this a b c d values. Given y of t is equal to 1 minus given y of t is equal to 1 minus 3 into e to the power minus t plus 3 into e to the power minus 2t into u of t is step response of the LTI system. Then calculate the frequency at which the force response is 0. Then calculate the frequency at which the force response is 0. So directly represent y of s is equal to simply 1 by s minus 3 divided by s plus 1. All simple questions only. 1 by s minus 3 by s plus 1 plus 3 by s plus 2. Upon simplification, what you will get? Denominator equal to s into s plus 1 into s plus 2, and here you will get s square plus 3s plus 2 minus 3s square minus 6s plus 3s square plus 3s. On simplification you have here is equal to s square 3s minus 6s and 6 get cancelled, and 3s square is cancelled. S square plus 2 divided by s into s plus 1 into s plus 2. This force response is going to be 0, and what value they are asking. By substituting simply s equal to j omega, this response is going to be 0 in nothing but this numerator is equal to 0. So this is equal to minus omega square plus 2 is equal to 0, and minus omega square equal to minus 2. Minus omega square plus 2 is equal to 0, right? S equal to j omega, simply substitute. That is minus omega square plus 2 is equal to 0. Minus omega square equal to this one, and this cancel omega equal to root 2. Omega equal to root 2 is the corresponding answer. Is the corresponding frequency at which the force response of the system is going to be 0. In the question they ask you the force response of the system equal to 0, or the corresponding filter, corresponding frequency not appearing in the output. At that situation, simply equate the value to the 0. At that particular frequency. Okay, next one. H of t is given as h of t is equal to 3 constant 3 from 0 to 3. H of t equal to constant 3 from 0 to 3. Constant 3 from 0 to 3 are equal to 0, otherwise x of t is equal to 5. The input x of t is equal to 5. Then y of t as t tending to infinity equal to how much? Then y of t as t tending to infinity is equal to how much? It is nothing but simply they are asking about the final value theorem. This corresponding value is equal to limit s tending to 0, s into limit s tending to 0, s into y of s. Here h of t equal to 3 they are giving. So this can be represented, the corresponding h of s can be represented as the 3 is nothing but this value is exists from 0 to 3. Corresponding value is equal to 3. So this is equal to 3 into u of t. 3 into u of t minus u of t minus 3. 3 into u of t minus u of t minus 3. The corresponding h of s is equal to 3 into 1 by s minus e to the power minus 3s divided by s. 1 by s minus e to the power minus 3s by s. So this can be represented as 3 into 1 minus e to the power minus 3s divided by s. 1 minus e power minus 3s divided by s. Here the input is equal to x into x of t equal to 5. This I am representing as a 5 into e to the power 0 t. 5 into e to the power 0 t. So corresponding output y of t is equal to simply 5 into e to the power 0 t into h of s at s equal to 0, h of s at s equal to 0, and at s equal to 0, what is this value? 3 into 1 minus 0, 1 minus 1 by 0, that is 0 by 0 form. At that situation, what I told to you in the calculation of Cn, if you get the value at n equal to 0 is of the form 0 by 0, then use the limit approach. Use the limit approach. That is limit s tending to 0. This value to be calculated 1 minus e to the power minus 3s divided by s by doing the L'Hospital, by applying the L'Hospital rule. What is L'Hospital rule? Differentiation of the numerator and differentiation of the denominator separately. Don't use u by v formula. Okay, so this is equal to limit s tending to 0. This value equal to 0 plus 3 into e to the power minus 3s divided by 1. So this value is equal to limit s tending to 0, 9 into e to the power minus 3s. This value is equal to 9. This value is equal to 9. This 9 to be substituted here. This so y of t expression will become y into 5 into 1 into 9, which is equal to 45, which is constant. So for any value of t, this value is 45 only, as t tending to infinity or t tending to 0 or whatever. Okay, t tending to 0 or whatever. This value is 45 only. This value is 45 only. Okay. All right, like that. Then if v of t is equal to sin t into u of t, the input v of t is equal to sin t into u of t. V of t is equal to sin t into u of t is given as input to the full wave rectifier. Then what is the Laplace transform of the output? V of t is equal to sin t into u of t is given as an input to the full wave rectifier. Then what is the corresponding Laplace transform of the output? What is the Laplace transform of the output? Here what I have given, input is equal to sin t into u of t. Here in simple question only, input is equal to sin t into u of t. This is given as input to the full wave rectifier. Then what is the Laplace transform of the output? What is the output of the full wave rectifier? Simply the corresponding output of the full wave rectifier is the positive part of this signal. This is the corresponding, this value equal to 0 to pi, 2 pi like that. 0 to 2 pi, 0 to pi, 2 pi like that. This is your output. Full wave rectifier output is produces like this. Okay, direct. You don't need to do analysis. Don't consider the two diodes. Two diodes of analyzation. For analyzation point of, we will see in the ADC. No problem. We will see in the ADC full wave rectifier point for rectifier. At that situation, we can show for this full wave rectifier, for this half wave rectifier, the expression for the frequency representation of the full wave rectifier and the half wave rectifier also very important. At that situation we will see the expression. Okay, depending on the expression, many applications are there in the EDC. At that situation we will see no problem. Okay, for half wave rectifier they given as a sin theta as the input, the corresponding output is equal to 2 pi. This is pi with periodic this is the corresponding output signal. Periodic signal with period is equal to 2 pi. Periodic signal with period is equal to 2 pi. If we are coming to the sin t full wave rectifier is given as the full wave rectifier, then the corresponding output is equal to periodic signal with period is equal to pi. Period is equal to pi. Here they have given input is equal to sin t into u of t. So the corresponding output of this full wave rectifier is the full wave rectifier is whatever I have shown here. This is the signal for this one. What is the Laplace transform of this one? Or they are asking. Already we have done the Laplace transform of this one. This is simply sin t into u of t multiplication of. This is simply sin t into u of t multiplication of the what is this? This multiplication of this signal with 0 to pi. The pulse signal of magnitude is equal to pulse signal of magnitude is equal to 1. Right? Already we have seen here. So this can be directly represented as the sin t into u of t. This directly can be represented as the sin t into u of t, sin t into u of t minus u of t minus pi. Okay, sin t into u of t minus sin t into u of t minus pi. Sin t into u of t minus sin t into u of t minus pi. So this can be represented as the sin t into u of t minus sin of pi minus t into u of t minus pi. So again this can be represented as the sin t into u of t plus sin of t minus pi into u of t minus pi, u of t minus pi. What is the corresponding Laplace transform of this one? If you want to consider only one part, this is the periodic Laplace transform. Okay, in that situation we have to take the part whichever is the repeating. For that one you have to calculate the Fourier transform, and after that the total Laplace transform this one is equal to simply f of s into 1 divided by 1 minus e to the power ts. This is the corresponding Laplace transform of this one. The Laplace transform of this one. This is your overall function, and this is your f of t. This is for f of t to be multiplied with this one. The corresponding Laplace transform is equal to 1 plus e to the power minus pi s upon 1 by 1 plus s square, 1 plus e power minus pi s upon 1 by 1 plus s square, 1 by 1 plus s square. Now the corresponding output expression y of s is equal to 1 plus e to the power minus pi s divided by 1 plus s square into 1 by 1 minus e to the power minus t is equal to pi only, period. So this is equal to e to the power minus pi s. This directly can be represented as 1 by 1 plus s square into 1 plus e to the power minus pi s divided by 1 minus e to the power minus pi s. This further simplification they have given in option, they have given in the further simplification. This value is equal to 1 by 1 plus s square into, by taking this half of this part as a common, you will have e to the power minus pi s by 2, e to the power pi s by 2 plus e to the power minus pi s by 2 divided by e to the power pi s by 2 minus e to the power minus pi s by 2. So okay, many questions we have done in this way also. Half part of this is taken as outside, half of this part is taken outside. So this will become 1 by 1 plus s square into cos h pi s by 2 divided by sin h pi s by 2. Here there is no j for writing, if cos h theta equal to e power theta plus e power minus theta by 2, cos theta equal to e power j theta plus e power minus j theta by 2. Here there is no j at all. So you can write this as directly 1 by 1 plus square into cos h pi s by 2 by sin h pi s by 2. Upon writing this one, further simplification, 1 by 1 plus square into cot h pi s divided by 2. Cot h pi s divided by 2. This may be the option available. In this way, the option may be available. In this way, the option may be available. Whatever the answer they will, whatever the variable they will ask you, you can calculate like this. Right? Oh, don't be confused. Full way rectifier, half way rectifier, whatever. Everything you know. Right? Then next one. F of t is real and even. If f of t is real and even, and having one pole at s equal to 5 plus 2j, and it is having one pole at s equal to 5 plus 2j, and few zeros at origin, and some zeros at origin, then what are the minimum number of poles and zeros? What are the minimum number of poles and zeros in the f of s? The given the signal f of t is of the real and even. Given the signal f of t is real and even. Given f of t is real and even, and they are saying that the f of s having the one pole at 5 plus 2j. If a complex poles always exist in the conjugate pair, one complex pole always exists in the conjugate pair, definitely there is one more pole at the 5 minus 2j. Definitely there should be one more pole at the 5 minus 2j. Be careful. Okay, real poles always exist in the single manner, or the complex poles always exist in the conjugate pair. Not only real pole equal to the real pole is in the single manner, and the conjugate poles always exist in the conjugate pair. Okay, then and after they are giving that what are some few zeros, some number of zeros at the origin, then what you have to calculate is the how many, for satisfying this condition, the minimum number of poles and zeros required for the f of s is equal to, they are asking. So now here see, as f of t equal to real and even, they have given very important this concept, f of t equal to f of minus, that is f of minus t is equal to f of t. F of minus t is equal to f of t. The corresponding Laplace transform is equal to simply f of minus s is equal to f of s. So this condition to be satisfied, f of minus s is equal to f of s. F of minus s equal to f of s to be satisfied. Now, if you consider some spectrum of this one, if satisfying f of s equal to f of minus 1, there should be symmetrical arrangement of the poles or zeros with respect to the vertical axis, with respect to the j omega axis. Then only we can call that f of s equal to f of minus s. So here they are saying that 5 plus 2 is one pole. So this is nothing but existed one pole at here place, and the conjugate of this one 5 minus 2j is existed this one. And some zeros at origin we will see later. Okay, some zeros at origin we will see later. For satisfying this one, For satisfying this one, f of s equal to f of minus s, there should be a two more force exactly in the opposite, in the symmetrical with respect to the j omega axis, with respect to j omega axis. So the minimum number of poles is equal to now. So if you consider the f of s, then simply this will become whatever the values here will become here, and whatever the values here will become here. So the corresponding expression will be same only. Right? Corresponding magnitude will be same only. And so the minimum number of force to satisfy this condition, is equal to 4. And what about the zeros? So we can represent this as the sum s to the power n divided by something whole to the power 4. This s to the power n, it is 1. S to the power n is divided by s to the power 4. To satisfy this f of s equal to f of minus s, the minimum value of n divided is equal to 2. S square only. If you consider yes, it is not satisfied. F of s equal to minus f of minus s, you will get okay. To get the even nature, the minimum number of n is equal to 2. So minimum number of zeros required is equal to 2 zeros. Like this we can draw. Like this we can calculate. The similar question can be correlated into the jet transform also. Be careful. Okay, jet transform also be careful. They will give you one pole into some 5 angle, some theta, pi by 2 degrees or 90. Some or 3 pi by 2. 5 pi by 3 they will give you. Okay, like this they will give you one pole, the corresponding one more pole you have to consider it the conjugate of this one. Okay, don't bother. Next one consider. Given h of s is equal to k into s square plus omega naught square divided by s square plus omega naught by qs plus omega square. What is the type of the filter it is? Okay, in the filter, for identification of the filter, you have to calculate. First, you have to calculate the expression at omega equal to 0. Second, you have to calculate the expression at omega equal to infinity. If omega equal to 0, for omega equal to 0 and omega equal to infinity, the corresponding magnitude, corresponding magnitude is finite, and this value is equal to 0. And the corresponding magnitude is equal to this value is 0 and this value is finite. Here equal to finite, and here also finite. Here is 0 and here also 0 and here also 0. And here is some constant value k, here also some constant value k, here also some constant value k, and here also some finite value is there, some finite value or some finite value. Here is also some finite value with some intermediate frequency. This value is equal to 0. At any some intermediate frequency, this value is equal to 0. These are the possibilities you may occur by substituting this omega equal to 0 and omega equal to infinity. In the first case, if it is finite, the corresponding all of these are the magnitude values. Magnitude at omega equal to 0. In the first case, the corresponding filter is simply your low pass filter, and for the second case, simply your high pass filter. And in this case, some finite value, simply you can call this is the some band stop filter. And the omega equal to 0 is 0, infinity this is 0, this may values in the particular band. Corresponding is the band pass filter. Here at omega equal to 0, this value equal to constant. Omega at infinity, this value equal to same constant, and this is independent of omega. K is constant, which is independent of omega. Then the corresponding filter is the all pass filter. Here K is constant, here all pass filter, and the final is some finite value. At intermediate value of this omega, any value between 0 to infinity, intermediate value of the omega at any value between 0 to infinity, this value is going to be 0. The corresponding filter is equal to notch filter. The corresponding filter is the notch filter. This you have to remember. Keep it in the box and put it 2 to 3 stars. Okay. Depending on this one, you have to analyze the nature of the filter. What they have given here, h of s equal to k into something they have given. So by omega equal to 0, that is nothing but s equal to 0 only. S equal to 0 only. What is this value? This value you will get is equal to some constant k somewhere. Constant k here. K into something. This can k in square is 0. This 0. This 0. K into omega naught square. Omega naught square. This value is equal to k. This value is equal to k. And omega equal to infinity. What is this value? Omega equal to infinity. What is this value? And omega equal to infinity also. This value is equal to k only. This value is equal to k only. K is constant and independent of omega. It may be all pass filter. Maybe all pass filter, and listen, maybe all pass filter. Now consider this at omega equal to omega naught I am considering. At omega equal to some intermediate frequency, if we get the all pass filter characteristics, we have to verify any intermediate frequency. If any intermediate frequency also we get the same value, we get the same magnitude, then definitely it is a all pass filter only. It is all pass filter only. In this case, these two cases, okay, in this case these two cases, don't say blindly all pass filter. We have to verify at some intermediate frequency also. At intermediate frequency also, this value equal to k only. Then you can say the filter is all pass filter. At omega equal to omega naught, this value is going to be what? At omega equal to omega naught. What is the magnitude of numerator? This numerator can be represented as the minus omega naught minus omega square plus omega naught square plus omega naught square. At omega equal to omega naught, this value is going to be 0. This value is going to be 0. So the characteristic of this may be like this. The characteristic of this may be like this. At omega equal to this constant, this slowly goes to 0, and after that again increases and reaches to the constant value k as omega tend to infinity. The corresponding filter is equal to notch filter. At any one value, this value is going to be 0. The corresponding filter is your notch filter. So the nature of this filter is the notch filter. Don't say all pass filter. Okay, don't say all pass filter. All pass filter, whenever you are having this situation k and k, you have to verify for the intermediate frequencies also. You have to verify for the intermediate frequencies also. Consider a question s minus 2 divided by, consider anything s minus 2 divided by s plus 2. Suppose h of s is equal to s minus 2 divided by s plus 2. The corresponding h of omega, h of magnitude of h of j omega is equal to omega square plus 4 divided by omega square plus 4 with square root. This value is equal to 1. For any value of omega, this value is 1 only, because omega of this h of j omega is independent of omega. H of j omega is itself independent of omega. This is constant. So for any value of omega, this value is equal to 1 only. So the corresponding filter is called the all pass filter. The corresponding filter is called as the all pass filter. All pass filter. So about all pass filter, be careful. And if one more example is equal to s square minus 2s plus 2 divided by s square plus 2s plus 2. By substitute s equal to omega, what you will get here is equal to simply 2 minus omega square minus j2 omega divided by 2 minus omega square plus j2 omega is conjugate of this one only. Numerator and denominator are conjugate each other only. Numerator conjugate each other only. Even if you take the magnitude for the z and z star having the same magnitude only, those are in the numerator and denominator. So this value is always constant. So for saying the filter is a all pass filter, the numerator by writing the expression of h of j omega, that numerator and denominator will may occur in the conjugate pair. Though the corresponding magnitude is equal to definitely 1, So you can say this filter is the all pass filter. This filter is the all pass filter. If the about the comment about the all pass filter and the notch filter, be careful. All of these directly you can say. For all of this directly you can say whether it is low pass filter, high pass filter, band stop filter, band pass filter. You can say this band stop filter sometimes they are causing as the band rejection filter. Okay, don't be confused. Band stop filter or band rejection filter, not whatever. Like this, you can calculate, or you can identify you have to identify the filter, which type of filter it was. Right, next one. Which type of filter it was, that like that you have to calculate. Then coming to